Hey guys, this is Miss Watson here, bringing you today's notes, and wanted to introduce myself here. I thought this was kind of a neat picture. This is from a couple years back. These are all math teachers. Now, most of you guys are freshmen, so you probably only had one teacher here, but that's me. Where the arrow is pointed, I was one of several Batman that year. This was Superhero Day during homecoming, and you probably see a couple of your other teachers here. Question is, can you find Mrs. Peters? Maybe next time I'll give another picture for you. But again, this is Miss Watson, and I hope you guys are doing well. All right, let's get to it. We're going to start with a little bit of recall. Zero product property, which we learned earlier this week and are going to continue to use today. So first problem I'm going to do for you as an example, and then ask you to try the second one on your own. So zero product property says that if two numbers multiply and equal zero, then one of them has to, at least one of them has to be zero. So what we do is we take these two, we set 3x and we set it equal to zero. And we take 4x minus 1 and we set it to equal to 0. Solve both of these for x, and you're going to get x is equal to 0. Do the same thing over here. Get x by itself, and you're going to get x is equal to 1/4. So two answers on this, okay? Both are correct answers. And if you only give one of them, then it's not fully correct. Okay, go ahead and try the next one on your own. Okay, so hopefully you did the same thing here. You set each of these terms equal to 0, like so, and then solve for 0. This one, I'm sorry, solve for x. This one you're going to get 0. This one over here, if you subtract 5 from both sides, you're going to get 2x is equal to negative 5. Divide both sides by 2, you're going to get x is equal to negative 5 halves. 5 over 2. It's a 5. So hopefully you got that as well. Okay, we're going to revisit that in part 3 of today's lesson. Okay, so part 2. A lot of this is going to be just more practice from yesterday's stuff. So if you were feeling good about yesterday, and this is going to be just some more good practice, and if you were feeling like yesterday was a little tough, then hopefully today, doing a second day of it, will help you out. So this is called moving forward. That's just a term that we use. Really, what you're doing is you're multiplying. Okay, you're putting it in vertex or in this form. This is factored form, and you're changing it to standard form. So remember, standard form looks like this: ax squared plus bx plus c. And the way we're going to do this is we're going to use a box method to basically distribute and multiply. Okay, I love the box method. Those of you that have me for class, I used it once before when we first started e-learning. Okay, so um, you see that this binomial is here, this binomial is here. It doesn't matter which one you put on top and which one you put on the left. Okay, you're going to multiply them. X times x gets you x squared. X times positive 5 gets you positive 5x. Negative 7 times x gets you negative 7x. Negative 7 times 5 gets you negative 35. What I like about the box method is that you typically end up with like terms right here. Okay, these are like terms. Terms are like if they have the same variable, in this case x, and the same degree on that variable, in this case 1. So then you combine those. So the answer in standard form would be x squared. Combine those two that I highlighted in yellow, minus 2x minus 35. And this is standard form because this matches that form right there. Okay, go ahead and try the next one. Okay, so hopefully you went through the same process, multiplying. You should have gotten 2x squared minus 4x plus 3x minus 6. Again, these diagonals are like terms, so you can combine them. So 2x squared, combine those two, you get negative 1x minus 6. Okay, now part 3, moving backwards. And this is really the stuff that we want the good practice on, because this is really what we're doing here is our goal is to solve. And in part 1, we solved by factoring. Okay, so if you're given the expression or the equation in standard form, you need to be able to factor it, write it in factor form, and then solve it using the zero product property. Okay, so I want you to take note of our steps here. Okay, Ms. Jaber went over these yesterday in her video. First thing, and this is going to be applicable going forward. We're not going to have any of these today, but I don't want to pretend that this step isn't there, is you want to look for GCF. If you recall from earlier today, GCF is greatest common factor. And factor it out if there is one. Okay. Step 2, play the X game. Okay. Step 3, create and fill in the box. And again, this is factoring using the box method. Okay, and now this is important. First and last term stay the same. But the middle term, you're going to split the middle term into the two numbers from the X game. And that's why we play the X game, because we need to know what those two numbers are. Okay, and we're going to do examples of these. All right, next step. Find the GCF. So we're going to do find the GCF of each row. It doesn't really matter if you do row or column first, but I always kind of do row, and then I do the same thing, find the GCF of each column. Now, I am going to put a note here. If the first term is negative, then you want to make the GCF negative, and we're going to have an example of that. Okay, but it's important to note, if the first term of the row or the column, whichever one you're doing, is negative, make the GCF negative. Okay, and I hope you're writing this down. And remember, you can pause the video if you need a minute to write this down if I'm going too fast. All right, almost there. Next up, you're going to write it in factor form. And that's based on the GCFs that you found. All right, and then once you have the factor form, what ends up happening, guys, is you have something like what's in example 1, okay, where now you can solve by using the zero product property. Okay, so these are the steps. I know it seems like a lot. I have found that it's just continued practice and independent practice, and that's where we're going to have you do some of these on your own to get you comfortable. Feel free to go back to these notes. These are really good steps to write down so you can go back to them whenever you're doing these problems. All right, so let's do the first one. All right, first thing is look for GCF, greatest common factor. There is none, so we don't need to worry about that. Next thing is to play the X game. So remember, the X game is two numbers that multiply to A times C and add to B. And so this is AX squared plus BX plus C. So I'm going to do it for this one. A is 1, B is negative 3, C is negative 28. So, excuse me, what we're looking for is we're looking for two numbers that multiply to 1 times negative 28, which is negative 28, and add to B, which is negative 3. Okay, you go through the process of the factors of 28, and then you see what combination between positive and negative do I need to get to negative 3. So it's going to be negative 7 and 4. Okay, so these are the two numbers that we're going to use to split the middle. Okay, Now we create the box, fill in the box. I always say it out loud when I do it. First and last term stay the same. So this is our first term, so that stays the same. This is the last term, that stays the same. And then split the middle term, right, which is this, negative 3x, into the two terms that we found, negative 7 and positive 4. So that becomes negative 7x plus 4x. Okay, and so again, play the x game so we can find those two, and then we split the negative 3 into those because negative 7x plus 4x is negative 7x. All right, now GCF. So GCF, I always do the rows, so GCF across of these two is just going to be an x. GCF across of these two is a positive 4. All right, go down. GCF of these two is just an x. GCF of these two is a negative 7. And this is the example where I'm telling you if the first term is negative and this first term is negative, right? So if that's the case, when you're taking the GCF, if the first term that you're taking the GCF of is negative, you want to make the GCF negative. And then this is our factored form now. So the factored form would just be x plus 4 times x minus 7, and don't forget your equals 0. Now, the question always comes up, doesn't matter which way you write it. No, it's a multiplication. It does not matter. You could have written it as x minus 7 times x plus 4. It's the same thing. Okay, last step, go ahead and solve it using the zero product property. So set each of these equal to 0. Some of you guys are probably pros at this now. And you're going to get x is equal to negative 4, x is equal to 7. And that is your answer. Okay? So again, what we did is we factored it, and that allowed us to go from standard form to factor form. And then once we're in factor form, now we can use the zero product property to solve. So this is why we care about factoring, is that it's one method to solve a quadratic. All right, go ahead and try the next one on your own. Okay, so I'm going to run through this one. There's no GCF, so I can go to step 2, which was play the x game. So this is a times c, this is b. So I'm looking for two numbers I multiply to 12 and add to 8. Okay, my two numbers are going to be 6 and 2. Because 6 times 2 is 12, 6 plus 2 is 8. All right, now I'm going to fill in the box. First and last term stay the same. Split the middle into the two numbers that you found from the x game. So this is going to be plus 6x plus 2x. And that's why we have to play the x game, guys. Okay, GCF of each row. This is going to be x. This is going to be positive 2. GCF of each column. This is x. This is positive 6. Here's our answer. So a factored form is x plus 2 times x plus 6 equals 0. Solutions, when you use a zero product property, set each of these equal to 0. You should get x is equal to negative 2 and negative 6. All right, we're going to just do a couple more here. All right, again, no GCF here, so we're just going to go into the x game. I was using blue. All right, so again, this is a times c, this is b. A times c is negative 24. B is 2. So two numbers I multiply the negative 24 and add to 2. It's going to be positive 6 and negative 4. All right, go ahead and fill out your box. First and last term stay the same. Okay, now we need to split this middle 2x into the two numbers that we found. So it's going to be positive 6x, negative 4x. Don't forget to attach the x on those. Okay, let's do the GCF going across. The GCF 3 and 6 is 3. The GCF of x squared and x is x. Down here, GCF across. Again, my first term is negative 4. It's a negative. So I'm going to make the GCF a negative. And between 4 and 8, it's 4. Okay, find the GCF going down. The GCF between 3 and negative 4 is just 1. And then between the x's, it's x. So I'm just going to make it x. And then between 6 and negative 8 is going to be positive 2. Once again, there's my answer, factored form. So 3x minus 4 times x plus 2 equals 0. We'll go into the extra step to actually solve it. Set each of these equal to 0. Okay. Move this over to the other side. You're going to get 3x is equal to 4. So x is equal to 4/3. Over here, you're going to x is equal to negative 2. So solutions are 4/3 and negative 2. Okay, go ahead, try the next one. All right. Hopefully you got through that okay. Here's our x game. A times c is negative 24 again, but this time b is negative 5. So the two numbers that we want to use are going to be negative 8 and positive 3. All right, fill in the box. First and last term stay the same. And then split this middle. So instead of negative 5x, we're going to write it as negative 8x and positive 3x. Like so. Okay, take the GCF of each row. This is going to be 4x. This one is going to be positive 3. Take the GCF of each column. This is just x. This, again, the first term is negative, so we're going to make the GCF negative. And then the GCF between 8 and 6 is just 2. The outside is our answer. So factored form is 4x plus 3 times x minus 2, and that's equal to 0. To go ahead and solve, set those each equal to 0. You're going to get x is equal to negative 3/4 and 2. All right, last set, guys. Now, I didn't put the boxes in for you because you're not always going to be given the boxes. So you just draw a box, and it works. So let's do one together here. Start by, is there a GCF? There is not a GCF between 4, 12, and 9. So we're going to start with the x game. A times c adds to b. A times c is 36. B is negative 12. My two numbers I'm looking for here are negative 6 and negative 6. Right? Because if I multiply those, I get positive 36. If I add them, I get negative 12. Okay, go ahead and draw a box. So when I draw a box, I just draw it like this. All right, first and last term stay the same. Split that middle into the two numbers from the x game. So instead of negative 12x, I'm going to split into negative 6x and negative 6x. Take the GCF going across. This is going to be 2x. This one, my first term is negative, so I make it a negative. Between 6 and 9, it's 3. Take the GCF going down. 2x going down. Again, it's negative, and it's 3. And if you see what happened here, these are the same. So factor form is 2x minus 3 times 2x minus 3. Okay, and then to solve it, so that's the factored form. And then if you're going to solve it, you're going to set each of these equal to 0. Well, look what happens when you do that. Aren't you going to get the same thing? And you do. And so what that means is, graphically, we'll probably see this later, that it is possible for a quadratic to have one solution. It looks different on a graph. You don't need to worry about that now, but just wanted you to see that it is possible when you factor that you get the same binomial multiplied by itself. Okay, and then so when you solve, you get the same answer. All right, try the last one on your own. All right, guys, hoping you're getting the hang of this. A times c here is 9, b is negative 6. Two numbers I multiply to 9 and add to negative 6. It's going to be negative 3 and negative 3. Let's go ahead and draw my box. First and last terms stay the same. Split this middle, negative 6x, into negative 3 and negative 3. Don't forget your x. Okay, take the GCF across, 3x. Take the GCF across, negative 1. Take the GCF down, 3x. Take the GCF down, negative 1. Oh, it happened again. What I mean is, it's a binomial multiplied by itself, and that is okay. That is not always going to happen, but it can happen, and it does happen, so we don't want you to be alarmed. So if you solve these for x, you're going to get x is equal to 1/3. So again, another example of only one answer because it's a binomial multiplied by itself. All right, guys, I hope this was helpful to have a second day of practice. Please reach out with any questions, or if you need more practice, please reach out to your teacher. Thanks so much. Take care.